The next unit we're going to study is Unit 2, which was at the beginning of the year. Our essential question for this is, how do I use scientific notation and exponents? How do I use scientific notation and exponents? We're going to start with scientific notation. So it says, what has to be true in order for a number to be written in scientific notation? Let's remember that that looked like a number in front times 10, and the 10 has an exponent that is a number as well. We need to add some to this. The number that's in front has to be between 1 and 10. It can be a decimal, and most of the time is a decimal, but it's between 1 and 10. And the exponent number that goes with the 10 is a positive or negative whole number. So it could be positive 3, it could be negative 7, but that exponent won't have a decimal in it. So when we change the numbers that are below from standard notation or normal looking to scientific notation, we have to think about where is the decimal point right now and where does it need to be between 1 and 10. So if I look at our first example, 2,540,000, I don't see a decimal point, which means it's right here at the end when it starts, and in order to put it somewhere where a number would be between 1 and 10, it needs to go right after the 2. Now I count how many times that has moved. 1, 2, 3, 4, 5, 6. I'm counting the spaces. So it moved 6 times. So my first number between 1 and 10 is 2.54. Then I put times 10, and since we moved it 6 times, I put 6 for the exponent. I have to decide if it's going to be a positive 6 or a negative 6. In this case, it stays positive because it's a very large number. So over here on the side, I'm going to write to myself that a positive exponent with scientific notation means a big number, bigger than 1, and a negative exponent with scientific notation will mean a smaller number. I'm going to say smaller than 1. So my next example, I can see that the decimal point is starting right here after the 0, and in order to make this between 1 and 10, I need to move it right after the 2. So I'm going to move it 1, 2, 3 times. So my front number between 1 and 10 is 2.76 times 10. I moved it 3 times, and because that number is smaller than 1, it's a small number, it's negative 3. 2.76 times 10 to the negative 3. Now I'm going to change numbers backwards, so from scientific notation back to regular looking numbers. I'm starting with 1.53 times 10 to the 4th. I'm going to write that number down one more time, and the 10 with the 4 tells me that I need to move this decimal place 4 times, and I need to make this number bigger because it's positive. So that means I'm going to move it to the right. So I'm going to move it 1, 2, 3, 4 times to the right, and now it's back here. 2 of those spaces are filled up with a 5 and a 3, but there's 2 moves that have no number in them, so I add a 0 for those 2 spots. I'm going to rewrite my number without the spaces involved so it looks a little bit neater. 15300, and add a comma so it says 15,300. The next one I'm going to do similarly, so I'm going to write down 2.84 to start. I can see my decimal point right there, and I need to move it negative 2 is my exponent. So 2 times to make this smaller, 2 times to the left. So 1, 2. It looks like only 1 spot needs to be filled. I fill it with a 0, and then I rewrite my answer, so my answer is 0.0284. Now, the next question says, how does your calculator show scientific notation? So sometimes your calculator would give you a number like we just got, 0.0284, and we would have to change it. Sometimes your calculator shows things differently. Your calculator sometimes shows it as the number that's in front And let's say again that that's between 1 and 10. And then it has the letter E and then some number. They are using the E instead of the times 10, and the number at the end is whatever the exponent number would be. So, right below, it says 8.758 E negative 11, and we're supposed to write it in scientific notation. Well, the number in front is still the number in front in scientific notation. It's between 1 and 10, but instead of E, I'm putting the times 10 in there, and the negative 11 is going to be the exponent. So it's pretty similar, just changing the E for the times 10. Now we're looking at exponents on the back. For each of these properties, we're going to solve the problem, simplify it, and write in a description of what it is. So the first one I see is product of powers property. What I'm really looking at is not the words, but the problem. 4 to the 5th times 4. First thing I noticed is that 4 does not have an exponent, so I need to give it an exponent. And remember, if it has none, it has a 1. So I'm going to add that over there. No exponent, add a 1. So now I see 4 to the 5th times 4 to the 1st. When I have a problem like this, I'm supposed to add the exponents, so I would get 4 to the 6th, and I need to write that my job for this is to add the exponents. For the next one, power to a power property, there's an exponent outside of another exponent, 4 to the 10, all to the 3rd. This is when I multiply my exponents, so I would get 4 to the 30, and I'm going to write that I multiplied the exponents. The third one, we've got quotient of powers property, 4 to the 8 divided by 4 to the 3rd. When they're on top of each other like this and they're dividing with the exponents, we subtract them. So this would be 4 to the 8 minus 3, that would give us 5. And we're going to write that we subtracted the exponents. Our next one is the quotient of a power property. It looks kind of like a mixture of the last two that we just did. Something's being divided and there's an exponent outside of parentheses. We want to distribute that exponent inside. So the top would look like 2 to the 40, 4 times 10, and the bottom would look like 3 to the 8. So I'm going to write that we distributed the exponent, and then we need to look at it one more time, because when our problem looked like this right above, we subtracted the exponents. We would do 40 minus 8. We can't do that this time though, because the bases, the big numbers 2 and 3, do not match. So we are done with that problem, and I'm going to write a note over here in the question column that we only combine if the bases match. So we could not do what we just had, 2 to the 40 over 3 to the 8. There's nothing else that we can do for that because the bases do not match. Moving on to our next property, the zero exponent property. We've got a lot of stuff going on in these parentheses, but it's all raised to the 0 power. And hopefully we remember our rule. Anything to the 0 power is 1. So this entire messy thing, because it is all to the 0 power, is 1. I'm going to add that for my words. Anything to the 0 power is 1. Last but not least, the negative exponents. This is when people are in a bad mood and you got to make them happy. Got to make them be in a good mood. So we talked about moving people in their house, making them go to their room. Right now I see 5 to the negative 7. I don't see a house. I don't see an upstairs or downstairs. I need to make it a fraction. So I put an over 1, then I can see the house. I see upstairs, I see downstairs. Someone is mad upstairs, I need to move them to the other part of the house. So I need to move them downstairs, and when I do, the 7 turns positive and they're happy again. Now there's nothing upstairs, so I'm just going to put a 1 up there. So I'm going to write for my words, move to other part of the house. And we know that when I say house, I really mean move to the other part of the fraction. Let me know if you have any questions, and let's start practicing.